Hi, this is Ms. Fitzmaurice, and this video is about working backwards from currents, voltages, and resistances to drawing an actual circuit. So what I need you to do is I need you to get out your packet, and you need to turn to page 23. And so the first chart that you see on page 23 looks like this, and it tells you the voltage, current, and resistance through each battery or through each circuit element, and then from that you have to work backwards to draw the circuit. Okay, so I'm going to start out, and what I suggest you start out doing is by looking at the battery. So I know that overall the battery has 12 volts and the current has 4 volts. So from this, I know I can calculate the equivalent resistance of the whole circuit. I know that Req will be equal to V divided by I. And so Req will be 12 over 4, which is 3 ohms. So I know in total my circuit should have a resistance of 3 ohms. I also notice, looking at my other elements, that since I have 12 volts for my battery, I also have 12 volts for my resistor 3, and what that means is that it has to be in parallel with the battery, or directly connected to the battery on both ends. So I have this resistance, or resistor 3, and I'm going to draw it just connected to the battery on both ends. So this is R3. And I notice that it has 1 amp going through it, so that doesn't tell me that much, but I know it's 12 ohms, and I can check V equals IR, and that works out. 12 equals 1 times 12. Okay, that's a true statement. I look at my other resistors, R1 and R2, and I don't notice anything about their voltages right away, but I do notice something about their currents. I notice that they have the same current as each other, so what that tells me is they're probably in series with each other. That's not always going to be true, but it's a good hint. So these two have to be in series with each other, and I can also tell that 3 plus 9 equals 12, so they add up to be the voltage of the battery. What that means is our series should be in parallel with the battery, and so I'm going to draw them that way. Okay, and so I have R1 and R2. And so I could go ahead and I could check whether it makes sense for them to both have or be in series with each other. I can check using the voltage divider, so I should check that since these guys are in series, I expect delta V1 is equal to delta V for my series, and since it's connected, my series is connected to the battery, that should be 12 times R1, which is 1 over R series, which is 1/4. And so I get delta V1 equals 12 times 1/4, which is 3 volts. And in fact, that is what I see up here. I can do the same thing for delta V2. It should be delta V series, which is 12 times 3/4, and I end up with 9 volts, which is in fact what I get over here. Okay, so I want you to go ahead and spend a few minutes trying to construct the circuit, the second circuit on this page, and then check back for the answers. Okay, so now that you've tried this for a minute, let's talk about it. So first of all, nothing has the same voltage as the battery, so none of our resistors can be directly in parallel with our battery. However, when we look at the currents, we see that R1 has the same current as the battery, and so what that means is that R1 has to be in series with our battery. So I'm going to draw R1 directly in series with our battery. Okay, you should also notice that R2 and R3 have the same voltage as each other, so they have to be in parallel with each other. So I'm going to draw R2 and R3 after R1 in parallel with each other. And we can check this a couple different ways. Okay, so first of all, we can check that Kirchhoff's junction rule is followed. Okay, so if I draw an X right here at this junction, we should expect all the current going in equals all the current going out. So we have sigma I in equals sigma I out. And the current going in is, of course, I1, and we want to know if it equals I2 plus I3. And when we go ahead and test it out, we see that I1 is 6 amps, I2 is 2 amps, and I3 is 4 amps. So it is the case that 6 equals 2 plus 4. So we've satisfied Kirchhoff's junction rule. We can also check, so we know that our battery is 18 volts. Kirchhoff's loop rule. So we have the change in voltage all around the loop has to be equal to 0. So if I check this red loop that I'm drawing right now, I have delta V battery, so that's 18, minus delta V1 minus delta V2, because I go through resistor 2, equals 0. And what that means is we have to check whether that's true. So I have 18 minus V1, which is 6, minus V2, which is 12, and 18 minus 6 minus 12 does in fact equal 0. So we're going to be doing this in class, not tomorrow, but on Thursday. And the reason we're going to be doing this is that if you have to work backwards, it really helps you to understand relationships within a circuit. So what does it mean if two circuit elements have the same voltage? What does it mean if they have the same current?